This is Linda.
Hi, this is Raj.
Today we're going to talk about our experiment on encoding a Sudoku as a three-set problem. This is an overview of what we're going to talk about today. First of all, our hypothesis. So encoding Sudoku as a three-set problem with layered approach will get better performance during the resolution with a SAT solver compared to the naive encoding. First of all, a three-set problem means that we want to encode our problem with clauses of maximum length 3. We used a layered approach, meaning that we grouped our variables and introduced some new commander variables in order to get to the three-set encoding. Better performances, we selected some matrices in order to compare the performance of the SAT solver in both the naive encoding and our encoding. We were inspired to go in this direction by a paper dealing with encoding KSAT problems and SAT performances.
So for our experiment, we have chosen 500 Sudokus of sizes 9, 16, and 25. We took this database from the mentioned website. So basically, it gives an Sudoku in a TXT format with the position and the number if it exists. And the SAT solver, we started with an picosat, but due to the lack of sufficient metrics available, we changed our SAT solver to minisat. And we got an improved version of the minisat where we can get all our matrices in a more easier way and a better way. So the basic matrices which we used for experiments are as mentioned in the slide. So CPU time is nothing but the total amount of time taken by the SAT solver to solve the given encoded CNF. And this is typically returned in terms of seconds. And memory usage is the same thing, similar to CPU time, but except that how much memory has been utilized by the CPU when the SAT solver tries to solve the encoded CNF. And the minisat is a typical DPL algorithm which uses to solve the SAT problem. So typically conflicts, decisions, and restarts are the techniques used in the DPLL algorithms. So the matrices which we used is like the number of conflicts occurred and the number of decisions taken and number of restarts happened while solving the given encoded CNF.
So we first started encoding the naive approach. That means that for each constraint we have, we encoded at most one and at least one of all the variables. The constraint we have that define the constraint that define the Sudoku problem are for each cell, for each row, for each column, and for each block. We want to see just one value between 1 and the size of the Sudoku. This gives clauses of length 2 for at most one variable and of length n, where n is the size of the Sudoku for at least one variable. Starting from the naive encoding, we then try to formulate the problem as a KSAT problem with k equal 3, 4, and 5, introducing some dummy variables to split the longer clauses. This revealed to be not the best approach. In fact, we can see from the plot that the performances of our encoding were way worse than the naive one. So we decided to try another approach motivated by a paper dealing with grouping variables.
We found out another approach within what we find it very interesting. So basically it's an 1 to n digit selection for CNF encoding. So if there are any clauses of higher size, what they do is like they divide the clauses into smaller groups and they give those smaller encoding clauses as an input. So basically they use an new variable called commander variable. They introduce this to each group, but it's the commander variables are introduced in such a way that each group follows some rules. So the basic rules are like in any given group, only one of the original variable can be true, and if the commander variable is true, then any of original variable has to be true, and if the commander variable is false, then no other original variable can be true. And by any chance, if there are like multiple commander variables in a group, then only one of them can be true. So we got motivated by this approach, and we introduced in our KSAT approach, and we used it for an K value of 3, and we made a group of 3 variables where 2 of them are the original encoded variables and one of them is a commander variable.
Let's take a look at the results of our experiment. After running the experiment, we found out that the number of restarts wasn't a good metrics for our comparison. In fact, over 90% of the Sudokus gave a number of restarts equal to 1. And we can see from the histograms that also the number of conflicts and the number of decisions doesn't really vary with the encoding. Our interpretation of this fact is that these values depend on the hardness of the problem and not on the encoding. We can see though that the CPU time and the memory usage really depend on the encoding. We can see that the CPU time is a bit better for our three-set approach and for the layered approach compared to the naive one, but for Sudokus of size 9, our three-set approach it's still a bit worse than both the naive and the layered. But increasing the size, we can see that there are huge improvements. In fact, our three-set and the layered approach get really better CPU time, and also the memory usage is decreased. And this still holds for 525, and in fact the difference gets higher. This will probably go on if we increase the size. Yeah.
So in conclusion, the layered approach which we followed with respect to all this given Sudoku encoding gives much better performance compared to the one layered approach or the naive encoding. So the possible future works, one analysis what we did is for the given 500 Sudokus, we found the mean and variance of the memory and CPU time as these were the most important metrics we found. One layered encoding has a slight better mean and variance compared to the three set. However, three set is much better than the naive encoding, especially as the size increases. So one possible future work could be optimizing our approach in further, such that the mean and variance of a three-set approach as well is much better than the one-layer encoding. So other possible future works are like people can try with a higher number of k value, for example, like a 5-set or a 9-set for higher order Sudokus. So we tried until 25 cross 25. So if it can be tried with then higher order Sudokus like 81 cross 81 with a higher value of 9, like 9 sat or something, which we expect to give a much better performance. Also, we used Minisat as our SAT solver, so we can use some other better SAT solvers like maybe Zcaf or any other future SAT solvers and experiment further on our experiments.
So in conclusion, we would like to thank our Professor Frank and our TA team. Thank you.
Thank you.